So what this one is asking you to do is to go ahead and solve for C. We used to call these literal equations also. So if you take the R is equal to the 9/5 times the C plus the 273 and 15, you can go ahead and multiply this through to each of those terms using the distributive property. So you have 9/5 of C plus you multiply the 273.15 times 9 and divide by 5. And when you do that, you end up with a value of 491.67. And that's going to be equal to the R. And so now you can go ahead and use that subtraction property of equality for both sides of the equation, where R minus 491 and 67/100 is equal to 9/5 of C. And then you can go ahead and use the multiplicative inverse there, where it's 5/9 is being multiplied by that, where C is equal to R, both sides of the equation, because it's the multiplication property of equality, minus 491.67 being multiplied by the 5/9. So what they wanted and expecting is that you're able to take literal equations and manipulate them to get the values that you need for the variables that are being defined. So if you'll go ahead and look at these two graphs again, you should be able to note that we have the temperature in Fahrenheit on this one, so observation there, and the temperature in Celsius there, and the reverse where this is Fahrenheit versus Celsius, and this is Celsius versus Fahrenheit. So when you look at those, you're going to see that the ordered pairs become inverses of each other. So basically your X here is 32 where your Y is 0, but then on this one your X is 0 and your Y is 32. So next you're going to look at some hexagonal tables that are going to be placed side by side. They have so many sides that they can be sat at, that's why they're putting them side by side. And so you have an equation that represents that situation where the number of seats is equal to 4 times n plus 2, which represents, like I said, the number of seats as a function of the number of tables, when the number of tables is going to be represented by the n. I would like you to go ahead and pause the video to explain why this equation actually represents that diagram there. So with that said, if they've got one table edge next to the other, you probably should not look at the first table for any clues, but go ahead and start looking at the second, third, fourth, fifth continued tables, because when you do that, you'll note that there can be a total of 4 people at those tables that are adjacent to 2 other tables. So that is the accountability piece for the 4 here for the number of tables, plus the 2 that is being added onto it at the end in addition to it for the pieces of that you have those end table pieces that have some extra seating. So go ahead and decide what domain makes sense for that, and you can write it as the D for the domain. And we actually use braces like this, and then the range values that you think make sense, and you can list some values in that make sense. So you should have that your domain is going to be any whole number of tables, because we're not using partial tables, and numbers that are multiples of 2 because of the fact of the number of seating pieces that you're looking at. So go ahead and write an equation that represents the inverse of the given function. So the given function is this S is equal to 4n plus 2. So basically solve for n. When you solve for n, you should follow the process using properties of equality and hopefully not make any errors. Even though we're human, we most likely will. Where you should have that equation for the number of tables. How many tables are needed if the following number of people are attending the party? So if you have 94 people attending the party, how many tables are needed? If you have 95 people attending the party, how many tables are needed? So if you look back at the equation and the situation that's given, S is the number of seats. Clearly, they aren't calling it number of seats, they're calling it people. So you can go ahead and put the 94 in for your value for the number of seats so that you can find out how many tables you need. So this is going to be the 92 divided by 4. And it's like 23 in a fractional table, I think. So clearly we're not going to make a fractional table because that would not be realistic. So you would just go ahead and round up so that there's seating for that individual. And then you would use the same process using substitution property of equality, where you go ahead and place the value in for the variable and subtract, and it gives you a fraction, and again that'll give you a value. And when you get that value, I think that one is definitely fractional. The other one wasn't fractional, I was looking ahead. This one was not fractional and this one is, so don't use fractional tables. So it's asking what domain makes sense for the inverse function, and is it the same set of values that you would have had for the previous. So you can have any number of seats for your domain, knowing that possibly is not going to be limited to some of the numbers as it previously was.